Okay, this is a web video on how to draw Lewis structures. The first thing about Lewis structures is that when we look at covalent bonding and drawing Lewis structures, there's two rules you need to know. Hydrogen and helium only need 2 valence electrons to be stable, and most other elements on the periodic table need 8 in order to be stable. The exception is boron. Boron will only need 6, and we'll talk about that in another lecture. The first step for drawing Lewis structures is to find the total number of valence electrons, or what I call the electron cache. So if we have something like water, and I ask for you to draw that Lewis structure for water, the first thing you'd want to look at is say, okay, hydrogen has 1 valence electron, and I have 2 of them within my molecule, so that's going to be a total of 2 electrons. Oxygen has 6 valence electrons, so I have a total of 8 valence electrons in this, or a total number of valence electrons for this molecule. If there are more than 2 atoms, the atom with the most places to bond into is the center atom, or the one that is the least electronegative. However, hydrogen is never central. So I look at water, which is the molecule we're trying to draw, and it has 8 valence electrons. So I think oxygen has to be the central atom because oxygen can form 2 bonds. It has 6 valence electrons, and it can form 2 bonds. So if there are more than 2 atoms, the atom with the most places to bond into is the central atom. So then step 3 says that I'm going to place a dash between the atoms in my water molecule. So here I am again, I'm trying to draw water, and I know that water has to have 2 dashes to represent those 2 hydrogens. My electron cache for all of this was 8 electrons, which we measured or calculated in an earlier slide. And so by adding these dashes here, I've used a total of 4 electrons. Each dash represents 2 electrons that are being shared. That's what the dash represents. That means I have 4 electrons left over. So step 4 will be having that structure with my, remember here we had 8 electrons, I used 4, I have 4 left over. Complete an octet or a duet with pairs of electrons. So in this slide, only oxygen needs more electrons. It needs 8 in order to be stable. So what I'm doing is I'm looking at oxygen and saying, this represents 8 pairs or 4 pairs of electrons, 8 in total, in order to complete the octet. Oxygen needs 2, 4, 6, 8 electrons, and that is what is around the central atom. Hydrogen only needs 2 electrons in order to be stable. Let's try just a few more, like how this would work on a couple other things that we have. What if we have hydrochloric acid and I ask you to draw the electron or the Lewis dot structure for hydrochloric acid? Well, the first thing I'm going to do is say, okay, hydrogen has 1 valence electron, chlorine has 7, so there's a total of 8. There is no central atom because there's only 2 atoms. I put a dash between the 2. That represents the use of 2 electrons, which are my shared electrons, which means I have 6 electrons left over to get this molecule stable. Hydrogen does not need any more electrons. Chlorine does. Hydrogen's in control of 2 electrons, which is represented by the dash. Chlorine, at this present point, is only in control of 2 electrons. It needs 6 more. So these 6 valence electrons are going to go around in pairs around that central atom. And that is how you would draw the Lewis structure for HCl. The Lewis structure for NH3, let's erase this piece right here. The first thing we would do is calculate the cash. Nitrogen has 5 valence electron, hydrogen has 1, but I have 3 of them, so that makes a total of 8 electrons. Nitrogen's going to be the central atom. It has the most places to bond into. Hydrogen is never central. Now I'm going to put a dash to represent the 3 hydrogen-nitrogen bonds that are in that molecule. So there's 2, 4, 6 electrons that I used to show the shared pairs, which means that I have 2 electrons left over. This now means that I have 2 electrons left over, and they would have to go on the nitrogen atom in order for nitrogen to complete an octet. Now, there's also a possibility that you could have a what we call a polyatomic ion. This is a polyatomic ion because it has more than one capital letter. It is actually covalently bonded, but acts as a group like an ion. This is called the ammonium ion. It is actually a cation because it has a positive charge, which means it lost 1 electron. If I ask you to draw the Lewis structure for this polyatomic ion, the process is exactly the same. We calculate the cash, which would mean nitrogen would have 5, hydrogen is 1, but you have 4 of them, so that's a total of 9 electrons. But the fact that there is a positive charge means that there is 1 less, so there is 8 electrons. Now when I draw this, nitrogen is still the central atom. Each dash represents a shared pair, and I use all 8 electrons with shared pair, and there are no electrons left over. Because this is an ion, you have to put it in brackets and show the plus charge. This is to represent that there is 1 less electron somewhere within that structure. I hope this helps, and I hope you guys have a good day.